Yes, same kind of guy. We are still on quinolones. Let's talk about the nalidixic acid and utilize the SAR. Yes, please don't forget to subscribe, like, and share this video to all those whom it may be helpful. About nalidixic acid, this is its structure. This is the structure of nalidixic acid. So we see these groups. Okay, this group, the carboxyl group. This carboxyl group is responsible for protein binding. So remember, the acidic drugs, they bind to albumin. And since this nalidixic acid has the carboxyl group, but there is no that basic group, so it is highly binding to albumin. Since it binds to albumin, much of it is filtered into urine. In the kidney. So it had high urine concentration. So this increases the urine concentration. It increases the urine concentration. So that's why it is, or it was restricted to the UTIs. Because it had low tissue permeability. Due to high protein binding, the tissue permeability was very low. And since it is concentrated more in urine, so it can be used to treat the UTIs, highly metabolized. But its metabolite, which is the 7-hydroxymethyl nalidixic acid at position 7, so at position 7 they added a hydroxyl group. This is the 7-hydroxymethyl nalidixic acid, and it is more active. It has more activity than the drug itself. Then this one continue to be metabolized to this. This is the 7-carboxy nalidixic acid. So this is the metabolism of the nalidixic acid. We are going to see, because this was the first quinolone, it was the first quinolone and had all these limitations and the others we saw previously. So how was it improved to make other quinolones? Here in SAR, we are going to see how was this improved to produce the other quinolones which have better activities. Let's see the SAR. remember we say that this is the general structure for all quinolones. Here we have an alkyl group. Here is R5, we have R6, R7, and R8. So we said according to the isosteric heterocyclic grouping, we can have these carbons substituted with nitrogen. So we saw that in the previous video. Now we say that pharmacophore is it is 1,4-dihydro 3-oxo. I mean 4-oxo 3 pyridine carboxylic acid. So this is the pharmacophore, this ring here with the carboxyl group and the ketone group. It is the pharmacophore. So it is very essential, it must be there, because this group is responsible for binding to the DNA. It binds the DNA such that there is inhibition of the DNA gyrase and topoisomerase for activity. Then this is position 1, 2, 3, 4, 5, 6, 7, and 8. At position 1, let's begin with, okay, before position 1, we have this bond. Hydrogenation of 2,3 double bond leads to inactive compound. If this double bond is hydrogenated or is made to be these carbons to be saturated, leads to inactive compound. We say these ones, they are responsible for binding to the DNA so that they need the activity of the DNA gyrase. Then position 1, okay, substitution of carbon with N, the nitrogen. It doesn't change the activity, because we saw we have N here in synoxacin, and we also have N here in nalidixic acid. So substitution, there is no change in activity. Let's talk about position 1. Position 1, addition of the alkyl group like the methyl, the CH3, the ethyl, or cyclopropane. We do like this. This shows that it is attached to the N. So improves the activity in this order. So with this one having the highest activity. So these ones, improves the potency. Improved potency, hence improve the activity. Activity is improved. Attachment of the allyl group. For example, this group which is 2,4-difluorobenzene. If it's attached to this group, it also improves the potency. We shall see the quinolones having these groups here at specific agents. When we go to position 2, position 2, 3, 4, substitution of these groups. Substitution. If anything is attached at this position, or substitute the hydrogens here, leads to inactive compound. So these groups shouldn't be compromised with. When you go to position 5, addition of the amino group at that position leads to reduction of the photosensitivity reaction or effect. Remember, these fluoroquinolones have this effect of photosensitivity. They are very photosensitive. So if there is an amino group at this position, that fluoroquinolone has low photosensitivity. For example, the superfluoxacin, we shall see them. Then addition of the methyl group improves the potency at that position. Then we have the position 6. The 6th position and the 7th position led to the fluoroquinolones. Fluoroquinolones, we have quinolones where we have all the Nalidixic and other quinolones. But fluoroquinolones are those with a fluorine at the 60th position. So substitution at 6th position and the 7th position, we are going to see it lead to the introduction of the fluoroquinolones. So the fluorine improves the potency. Hence, improve the activity. Potency and tissue penetration. Improve the tissue penetration. It also improves the activity against the gram positives. This fluorine group, the fluoride group. Then position 7. Addition of pyrazinoline. And 3 amino pyridiniline. These two rings, this Here it is attached to the position 7 and this one. These groups lead to improved activity against the Pseudomonas aeruginosa, the resistant gram-negative bacteria. The Pseudomonas aeruginosa. Remember, the first quinolones, like this Nalidixic acid, had an activity against this Pseudomonas aeruginosa. But addition of these groups led to improved activity. But these groups led to effects like the senescence effects, senescence side effects, like agitation, irritability, insomnia, tremors, among others, due to inhibition of the GABA, they inhibit the GABA receptors. Then, addition of a methyl group to this nitrogen of the piperidine, I mean the piperazinaline, reduced the senescence effects, senescence side effects. So, this one reduces the binding to the GABA receptors. So, this is the position 7. When you go to position 8, this position, if you add a methoxyl group, this one reduces photosensitivity side effect. We saw also this group, the amino group at position 5 also reduces the photosensitivity side effect. This group also improves the tissue penetration, so it improves the potency. This very group also has or improves the activity against the anaerobes, that group. Then, if you add a halogen at that position, there is improved photosensitivity. We shall see them in specific agents, those which have the halogen at this position, and those which have the methoxyl group at this position, even those with amino group at position 5. Yes, thank you for watching. It's Same Guy. Please don't forget to subscribe, like the video, and share.